സോ നമുക്ക് അബ്സലോൺ ഈക്വൽ ടു ലാസ്റ്റ് ക്ലാസ്സിൽ കിട്ടിയത് അബ്സലോൺ ഈക്വൽ ടു 1 പ്ലസ് റൂട്ട് ഓഫ് 1 പ്ലസ് 2ES ബൈ സെറ്റ് പ്രൈം ഇ സ്ക്വയർ ദി ഹോൾ സ്ക്വയർ എന്നാണ് നമ്മൾ ഇക്വേഷൻ നമ്പർ 12 ആയിട്ട് കൊടുത്തു. ഇനി നമ്മൾ കണ്ടുപിടിക്കാൻ പോണത് ഇമ്പാക്റ്റ് പാരാമീറ്റർ, അതായത് എസ് ഇൻ ടേംസ് ഓഫ് ദ സ്കാറ്ററിങ് ആംഗിൾ തീറ്റ. അപ്പോൾ അത് കണ്ടിന്യൂഷൻ തന്നെയാണ്. So we have the equation of orbit and then 1 by r is equal to mk by l square into 1 plus epsilon cos theta minus theta prime. Now set theta equal to 0 and theta prime equal to theta. So which corresponds to the periaxis. So we can write 1 by r is equal to, substituting these two values, so we will get this equation. In the next step we will get 1 by r is equal to m into z prime e square by l square into epsilon cos theta minus 1. So which corresponds to the hyperbolic orbit equation. And we have the equation for ellipse from Kepler problem, which is equal to 1 by r is equal to mk by l square, or some constant, into 1 plus epsilon cos theta minus theta prime. So comparing A and this equation 13. Okay, so the only difference is in the sign. Now coming to scattering again, this capital psi is the direction of the incoming asymptote. So when r is equal to infinity, then what will be psi? Then equation 13 will become, when r is equal to infinity, 1 by r is equal to 0. So equation 13 will become 0 is equal to mz z prime e square by l square into epsilon cos theta minus 1. So in order to make this LHS 0, this can't be 0. So we can write epsilon cos theta minus 1 should be equal to 0. Okay, so epsilon cos theta minus 1 equal to 0. Since theta and psi are directly dependent, so in the place of theta we can write psi because they are directly dependent. Okay, so epsilon cos psi minus 1 equal to 0. So from this we can write cos psi is equal to 1 by epsilon. Okay, and note that epsilon is the eccentricity here. So we have this equation, that is from the figure, from the previous figure, theta is equal to pi minus 2 psi and psi is equal to pi minus theta by 2. Then what will happen to this? Cos pi minus theta by 2 is equal to 1 by epsilon and this quantity is the sin theta by 2 and that is equal to 1 by epsilon. Okay, so using this trigonometric relation, that is sin square theta by 2 plus cos square theta by 2 equal to 1, we can write what sin theta by 2 is 1 by epsilon. So in the place of sin square we can write 1 by epsilon square. Okay, so 1 by epsilon square plus cos square theta by 2 is equal to 1 and so we can write what cos square theta by 2 is equal to 1 minus 1 by epsilon square and what is cot square theta by 2? The trigonometric relation cot square theta by 2 is cos square theta by 2 by sin square theta by 2. Okay, so we know what is cos square theta by 2, it is this value. So substitute here 1 by 1 minus epsilon square and sin square theta by 2 is from this C. So 1 by epsilon square, cross multiply and cancel the common terms. So we will get cot square theta by 2 is equal to epsilon square minus 1. Okay, so from that we can write what is cot theta by 2, that is equal to square root of epsilon square minus 1, put it as equation number 40. Now substitute the value of epsilon. Epsilon the value, it is epsilon is equal to root of 1 plus 2 es by z prime e square the whole square that we derived in the last class. So substitute that value here. You will get the plus and minus ones are cancelled. So we will get cot theta by 2 is equal to 2 es by z prime e square. Put it as equation number 15. Okay. So from this equation we can write what is s. S is equal to z prime e square by 2e into cot theta by 2. So now this is the relation between the impact parameter s in terms of scattering angle. Now this for problems. Okay, now we have the relation for the scattering cross section sigma of theta. Sigma of theta is equal to, from equation number 6 it is, or equation number 6 is s by sine theta into ds by d theta. Now we found out what is the impact parameter s in terms of scattering angle theta. Now substitute equation number 16 in 6. So we will get sigma of theta. This is sigma of theta actually. Okay, sigma of theta is equal to z prime e square by 2e into substitute the value of s here. So s is what, from equation number 6 it is z prime e square by 2e cot theta by 2 and divide by sine theta and ds, that is the derivative of cot theta by 2. So the constant came here and cosec square theta by 2 into 1 by 2. So now the constants the whole square and cancel the common terms here, and in the next step you will get sigma of theta is equal to these are just the mathematical ones, so I am not explaining it now. Sigma of theta is equal to 1 by 4 z prime e square by 2 e the whole square cosec raised to 4 theta by 2. Okay, now this is the differential scattering cross section. Okay, it is also called the Rutherford scattering cross section because it is derived by Rutherford for scattering of alpha particles by atomic nuclei. Now, in atomic physics, the concept of total scattering cross section is defined as, or for the atomic cases, the total scattering cross section, it is denoted as sigma suffix t. Sigma t is equal to integral 4 pi sigma of omega d omega. Okay, and we know what is d omega, the solid angle, which is 2 pi sine theta d theta. So put the value. So 2 pi comes outside. Sigma t is equal to 2 pi integral over 0 to pi sigma of theta sine theta d theta. Okay, now this is the relation between theta and s. Okay, this is the relation between the total scattering cross section and scattering angle theta. Okay, now I am stopping here. Anyway, I prefer you to read the text very well because in there it explains some different types of phenomenon due to scattering. Some of them are rainbow scattering and what is orbiting or spiraling, also glory scattering. So read the text very well. Okay, when s varies, that is the impact parameter varies from infinity to 0, that is when the impact parameter decreases, what happened, theta varies from 0 to pi, that is theta increases. That is the relation that we got from here.